GCSE question of the week, week 27. Okay, so we've got a circle with two individual circles inside it. Question 1. What's the difference between the circumference of the large circle and one of the small circles? Okay, right, what's the difference here does not mean one's bigger than the other. Okay, difference has got a very specific meaning in maths. It just means subtraction. Okay, so we need to take away one number from the other. Alright, so that word there is crucial. You are going to get no marks for saying one's grey, one's white. That is not what it means. So what's the difference between the circumference? That's the second key word we need to worry about. Right, you should be going into your exam knowing straight away, right, as soon as I see circumference, I need to know this formula. C equals pi d. Okay, right, we've been through the mnemonics before. Either cherry pie is delicious or just you learning it, you need to know that formula. Okay, what's the difference between the circumference of the large circle and one of the small circles? Alright, so let's work out the circumference of the large circle. Okay, so they're trying to trick us here. We've got C equals pi d. We've got a radius of 8 centimetres. So we cannot plug that 8 straight away into our formula. We want the diameter. But that's easy, isn't it? If the radius is 8, the diameter all the way across is that distance, is 16. Okay, so we want for the large circle, C equals pi times 16. Or C equals 16 pi. That's how we'd normally write that. Right, it says give your answer in terms of pi. So I'm not going to put that into a calculator. We're not going to find out what that is. We're not even going to approximate pi to 3 and do 3 times 16. We're going to leave it as 16 pi. That's exactly what the circumference of this circle is. Now we need to find the small circle. So the small circle, one of these, we've got C equals pi d again. Now this time, they do give us the diameter. We want the 4. We haven't got to halve it. We haven't got to double it. The diameter's labelled. So we've got C equals 4 pi. Okay, and the answer to our question was what's the difference between the big one and the small one? Well, that's 16 pi. Take away 4 pi. And that gives us 12 pi. That's our answer in terms of pi. Okay, question 2. Work out the area of the shaded region. Right, again, work out the area. You should be thinking straight away, I need this formula. A equals pi r squared. That's the area of a circle. So apple pies are 2, or you've just learned it. You need to go in, not getting muddled up between these two formulas. Okay, A equals pi r squared is going to tell us the area. We want the area of the shaded region. Okay, so the shaded region is that grey part. So I think we need to work out the area of the large circle, including everything, that whole circle. When we know that, then we could subtract the area of those two small circles. So let's do the area of the big one first. So the area of our big circle, area big, equals pi times the radius squared. Now the radius of that circle was the dimension they gave us, it was the 8. So we need to use the 8, not the 16. And that's going to give us pi times 8 squared. Okay, or 8 squared, 64. Remember, we only square the 8, not the pi. So it's going to give us pi times 64, or 64 pi. That's the area of the big circle. Okay, now let's do the area of one of the small circles. So we can put area small. So we need the same formula, pi r squared. And we need to do pi times the radius squared. Now we need to be careful. Okay, because the radius of one of these small circles is not the 4, is it? The radius is 2. The 4 was the diameter. So we need pi times 2 squared, which gives us pi times 4, or 4 pi. Right, but obviously we've got 2 of these circles. So we're going to need to subtract the area of 2 of those circles. So let's calculate the area of 2 small. And the area of 2 of those small circles is just 2 lots of 4 pi, which is 8 pi. Okay, so we can now work out the area of the shaded circle. We want the shaded region, and the shaded region is all of that, but not that, not that, not that. So we want the area of the big circle. Let's put area shaded is going to be the area of the big circle, which is 64 pi, subtract 2 small circle areas, which we already did was 8 pi. So the area of that shaded region is 56 pi. Okay, so we've got 56 pi is the area of the shaded region. And that is the area, that's in centimetres square, square centimetres. But this time it says give your answer, give your answer to 1 decimal place. It does not say give your answer in terms of pi. So we better do that. What is 56 pi? Okay, so we want to know what 56 pi is. Right, 56 pi equals, best to do it, we get 175.929. So what's that to 1 decimal place? Well, it looks to me as if it's 175.9. The 2's out of cider, doesn't round the 9 up. So our final area of the shaded region is 175.9. 175.9 square centimetres. And I guess really we should go back to the answer in number 1 and add our units, which was centimetres, because that was a circumference. Okay, so number 1 was 12 pi centimetres, and question 2, our area was 175.9 square centimetres. Well done. Okay, slightly harder. A shape is made up of 2 circles. The diameter of the large circle is 12 centimetres and the area of the shaded region is 50 square centimetres. Find the diameter of the smaller inner circle. Well, this has got to be something to do with our area formula, hasn't it? Because we know that the area of the shaded region is 50. And how do we make up the area of the shaded region? Well, I think the area of the shaded region, area shaded, has got to be equal to the area of the big circle. And by big circle, I'm talking about the area of the circle with radius 6. Subtract the area of the small circle. And by the small circle, I'm talking about this circle here with radius unknown. Okay, the area of that shaded part has got to be the area of the whole thing. That's to the outside edge of the blue thing. Subtract the area of the little white bit in the middle. Okay, so can we write an expression for that, or an equation for that, sorry. Yeah, of course we can, because we know the area of the shaded is 50, so we can put a 50 here. And the area of the big circle, well, that would be pi r squared, pi times r squared, where r squared is 6 squared, so we've got 6 squared, which is 36. Subtract the area of the small circle, well, that's going to be pi times r squared. So let's tidy that up a bit. We've got 50 equals 36 pi minus pi r squared. Okay, so we could factorise that pi. 50 equals pi 36 minus r squared. Okay, then we could do 50 divided by pi. So 50 over pi equals 36 minus r squared. Then we could rearrange for r squared. I'm going to add r squareds to both sides. That'll give me 50 over pi, and if you can do this in one go, brilliant. I'm going to do it in 2 steps. 50 over pi plus r squared equals 36. Therefore r squared equals 36 minus 50 over pi. Now we could have put some of those numbers in calculators earlier, but we've got one expression here, no rounding till the end, which is great. Okay, so we know how to get r squared. Let's find out what that is. Okay, we've got to do 36 minus 50 over pi. Let's try 36 minus. Now we need to put that in brackets. Now you might want a fraction button there. I'm old fashioned. I would have gone for 50 over pi, but let's put it like that. Okay, that way we didn't actually need the brackets. 50 over pi. Okay, that looks good to me. We want 36 subtract 50 over pi. That gives us 20.0845 for r squared. So I'm going to put down 20.08. But just to remind me, I've got that number in my calculator. We'll put some dots, so that carries on. Okay, so r squared. How are we going to find out r? We're going to find the square root of that 20.08. But I've still got it in my calculator, so there's no rounding. I'm going to square root my answer. That gives me 4.48. And that carried on. Okay, the question was find the diameter of the smaller inner circle. Well, we're nearly there. We know the radius. If we want the diameter, we just got to double the radius. Okay, so the diameter is going to be our 4.48 blah 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 number multiplied by 2. And again, no rounding, it's all in my calculator. Okay, I've got the whole number there, and we can multiply that by 2. And then the only rounding we have to do is at the end. So it doesn't specify, so I'm going to equate this to 2 decimal places, or 3 significant figures. Okay, we've got 8.96. And that's in centimeters. Where's that digit gone? Thank you. 8.96 centimeters. Okay, now is that a reasonable number of significant figures? Probably not. No, probably 2 would have been better. Okay, we've got diameter to 2 significant figures, area of the shaded to either 1 or 2, we're not quite sure. Probably 9.0 would have been better. Alright, but if it doesn't specify, you're not going to lose any marks there. Okay, so 9.0 centimeters or 8.96 centimeters to 2 decimal places, or to 3 significant figures. Done.